Hello everyone. My name is Jayavardhan Shukla, and today I'm excited to present on this topic building interactive tours with KML for Liquid Galaxy. This presentation explores how we can leverage KML files to create dynamic and immersive geospatial experiences. First we would discuss what a KML is. Keyhole markup language is basically an XML tag based language which can represent and visualize geographic data on virtual globes such as the Google Earth. So it was originally developed by Keyhole Inc., which was a company which was later acquired by Google in 2004. In 2008, KML became an open standard under the Open Geospatial Consortium (OGC). So why KML? Because it simplifies the geographic data visualization. Supports a variety of features such as points, overlays, annotations, and animations. Uh, and it helps us to create custom overlays, interactive maps, and so on and so forth. So the key features of KML include geographic features like creating place marks, lines, and polygons. We would discuss about them later. Camera views, we can customize map angles and zoom. Interactive tours, we can develop automated fly-throughs with tools that combine animations and visual data. Multimedia integration, we can embed images, videos, links, and so on using cloud balloons and other features of KML. Multi-screen experiences can also be done through seamless content synchronization and perfect, which is perfect for platforms like Liquid Galaxy. Now we are going to discuss the base structure of a KML. On the left side is basically a sample KML file. The top of the KML represents this KML tag, which is basically the root element. It acts as a container for the rest of the KML data. It contains everything enclosed within it. The next thing after KML is the document tag. So document tag contains all the KML objects, place marks, icons, network links, folders, our tools, and anything that we create would be contained in a document. It serves as the primary organizational unit within a KML file. It groups multiple elements like place marks, overlays, and tools, and it often includes metadata such as a document name and description. So right now we can see that there is a place mark which with a name specified inside it. So now next inside the place mark is basically the point tag. In the point tag we can specify the longitude, latitude, and the altitude of a specific place, and the place mark would be added to that particular coordinate. Just how we have opened our tags, we also have to close them in the same order, just like we do for XML or other HTML based tag based languages. So now next we are going to discuss the core KML elements. So we can see that there are two base elements, place marks and overlays. So place marks represent specific geographic points, include metadata, name, description, and style. So here we can see that in this image a place mark is added over the Eiffel Tower, showing where it is located. We have added the coordinates of Eiffel Tower here inside the point tag as discussed previously. We can add a description and a name of the place mark, so it would display right here. So the next thing is overlays. So we can use overlays for displaying images, videos, custom elements, which can also include the HTML elements over a geographic region. So overlays can be of three main types. The first is the ground overlay, which places an image on the terrain. So the image basically consumes the style of the terrain. Second is the screen overlay, where anchors are attached to the screen. Objects are visible and consume a specific portion or pixels of the screen. Next thing is the create a photo overlay, which creates an immersive panoramic experience. So we're gonna see these three overlay styles through an example in the next slide. So we can see that different overlays are there. Ground overlay is basically above the ground terrain, and the screen overlay is above the screen, consuming specific pixels. Photo overlay basically comes over the screen as well, but in the form of photo. So this is the major difference between the three. So there are other important KML elements like network link, lookat, and region. So network link basically dynamically fetches and displays the remote KML files. It is useful for updating content without editing the primary KML file. So we're gonna see how this works. This is a primary network link tag. We can see that name is given and all the important information is contained within this link element. So it contains href, which is basically the link of the KML data resource, which we are gonna use. Refresh mode sets the refresh interval for the KML file that we are loading. So refresh interval is important to give because the KML elements need to be refreshed in order to be rendered on the screen. So if we are setting the refresh mode to be on interval, then we also have to set the refresh interval, which is basically in seconds. So next thing is our look at element. It specifies the view perspective for a geographic location. For example, the longitude, latitude, and altitude basically covers the point or location where we have to go to. Heading is basically a term which is taught in surveys. It is basically the angle made from the north direction. So the angle heading at the north is going to be 0. The tilt is basically the angle made from the horizontal, and the range is basically our looking capacity at that particular point. So for 2D, the range is basically similar. We are seeing from the 1000 units from every direction. So this is how the locate element works. We are going to see about the locate elements in the future also a bit. So the next thing is region. Region basically defines the geographic and visibility constraints for big data sets. It improves performing by rendering only the relevant data. So for region, one thing to note is that we have to provide the bearings, which is north, south, and east and west bearings of a particular place, so that it creates a region out of that. So for instance, here we can see that we have provided the bearings of these in the lat lon alt box tag. So after that, there is LOD tag where we have to specify the pixels, maximum and the minimum pixels. Um, the maximum LOD pixels can be -1, and minimum LOD pixels is specified as 128. So this is how we can define these tags. Now we are going to move forward to the next section. So the next section is about tools in KML. So why tools are important? Because these are a sequence of pre-recorded navigations. We can move to different places, one after the other, through visual and sidewise integration of various animations that we can create. Uh, we can guide viewers through geographic content in Google Earth or similar platforms. These various camera movements, pauses, and overlays are combined for engaging and interactive experiences via the tours. So there are various core components of tools. Some of these are listed here. The tour is basically the main container. Playlist organizes the sequence of tour actions, like the places we're gonna go. That is going to come under the playlist tag. The fly to tag basically moves to specific position one after the other. It handles smooth transitions and navigation in specific points. One of the important tags inside fly to is the duration, which specifies under how many seconds we have to go from one location to the other. So the next thing is the wait, which introduces pauses between the actions, and animated update, which dynamically changes the styles or features during the tour. So how can we create a tour? So for this, we have to first define the tour element. We have to define the playlist tag and ensure all our actions are within the playlist tag. Then we can add tour actions like fly to, animated updates, and sound cue. The sound cue basically is a tag which plays the audio clips for the tours. So now next we can save and test in Google Earth for the fine experience. So there are various applications of KML tools. A few of these are listed here. These are immersive data visualization, environmental monitoring, global infrastructure projects like guided stakeholders through these basically help to guide stakeholders through planned and completed infrastructure developments such as roads, bridges, and energy grids using detailed flyovers. So next is geospatial storytelling, which highlights cultural, historical, or scientific narratives, which with visually compelling animations and audio guides. So training and simulation can also be done. Five routes for training pilots, emergency respondents, and urban planners. And finally, there is public outreach element associated with these KML tours. So these are some of the applications of the KML tools. Finally, we are going to discuss about the most important elements of creating beautiful tours. Most important, some of these include camera movements. So, camera movements basically define how the viewer's perspective navigates to the map, creating dynamic and immersive visual experiences. In this example, we can see how the camera moves beautifully and follows this blue line across the road. So we can see how beautifully this transitions from one location to the other while also covering the main point. So this is the main objective of camera movements. It basically sets up the whole angle and content for your tour. So fly to is the tag which handles smooth transitions between views. Orbit adjusts our heading and the roll for circular motions. Roll is something which is associated only for circular motion. It defines how frequently are we rolling across 360 degree in a specific point. Zoom basically modifies our altitude and range. Animated updates basically helps us with the animation thing. So the next we are going to discuss about the core elements for camera movements. These are camera and locate. So camera basically defines the camera's position in the 3D space, like where we have to go and point our camera to in Google Earth. So key parameters include longitude, latitude, and altitude, which define the camera position. The heading, which is the direction of the camera faces. Tilt, which is the angle from the vertical, and roll, which is the rotation around the viewing axis. So now next thing is basically the look at the point look at tag points the camera to a specific target. The key parameters include same longitude, latitude, altitude, heading, and tilt. However, we can see that the difference is that there's a range parameter with look at which specifies the distance between the camera and the target. So this is the key difference between camera and look at. If we wanna do a 360-degree rotation, then we are going to select the camera tag. If not, we want just distance based view of a particular region, then we are going to use look at. So next thing is place marks. Place marks are important features which can basically helps us aid us in our tour. So key elements of place mark are first of all the container place mark tag, which contains latitude, longitude, altitude, and name. Next thing is point. Point defines the exact location of the place mark. Balloon basically displays the additional information when the place mark is clicked. It can include HTML content like text, images, or links. So icon style is the next one, which customizes the appearance of the place mark with an icon. So here we can see that our icon for a place mark is a bit different than we have used previously. This is because we can use a separate icon using the icon style tag. So we can provide the href for the icon image, whatever icon we want to use in the place mark, and scale basically adjusts the how big or small we want the icon to be. So these are two important tags that you can use with the icon style. The example KML here demonstrates a Statue of Liberty. Uh, so we can see that the description, name, and place mark tag opening is there. We have specified point coordinates and then close the file. This basically puts the place mark right in the Statue of Galaxy coordinate. So the next thing to focus on is waiting and pausing. Waiting specifies the halts which are to be done in the tour. Halts means that we have to pause, not pause, but wait for the movement of the camera during the tour, but simultaneously allowing other actions like sound files, animated updates, etc. to continue. So this basically keeps the whole tour process to continue while stopping for a certain period of time. We can specify the period of time using the duration tag. Like here we can see that the duration is set to 10 seconds. So this is about the waiting tag. Next thing is pausing. So pausing can be done using the tour control tag. So play mode specified as pause, which means that until and unless the user dynamically chooses to make it resume, this is not going to open, basically make change. So the next thing is altitude modes. So there are three altitude modes: the climb to ground, the relative to ground, and absolute. So we can see these better using the examples here. We can see that the absolute altitude mode just places the our object in a specific altitude. So we can see that the mountain is cutting over the object because we are just placing it over a certain altitude. There's no control method how it, and option for us to basically decide how we are going to present this. So this is a simple version for the altitude mode. The object is placed at a specific altitude above sea level. There's nothing we can do relative to the relative position of the altitude in the ground. So the other things include clamp to ground and relative to ground. So clamp to ground object basically is placed directly on the terrain. It ignores the altitude values, whereas in relative to ground, it altitude is also added to the ground elevation, and object is placed at a high height relative to the terrain. So we can see that in the related to ground, object is placed at a certain height related to the overall terrain. It looks like as if the windows are created inside in the wall of the mountain itself. So this is the flexibility that we can obtain from the related to the ground thing. The next thing is clamping to ground. Basically, the image is clamped to the whole ground terrain all at once. So these are the three different altitude modes. So the next thing is animation and 3D objects. So we can define the 3D objects in KML with the help of KMZ, which is the compressed zip of a KML file along with the 3D objects. So for 3D objects had to be in the Collada or .dae format. We have to ensure that all the associated textures are saved in the same folder as the .dae file. So we have to organize our files like creating a Corada file, any texture files, and the KML files in the same folder, and then selecting all and then compressing them into a zip file. Then we finally rename the zip file into the KMZ file and test it in the Google Earth to see our object in the desired coordinate. So we can also animate the 3D objects in the KML. So this basically helps us to create beautiful animations in the 3D objects like rolling, moving to specific places, changing dimensions, and so on and so forth. This can be done using the animated update tag. We can specify the duration of the animation. We can basically use the update tag to describe the changes that we want. So each model in the KML is described using the target ID. So we have to specify the ID with which the model can be identified. Next, we can specify the location, altitude, and longitude, latitudes of that place where the 3D model is to be there. Then we can change the orientation using the orientation tag. We can basically allow for tilt and heading and roll. Then finally, this is the animation. So we can define the tour, move the object dynamically, add camera, and set durations. This is how we can create the 3D objects in KML. Next thing is that one of the most important things for creating tour is to enhance the performance. To ensure smooth performance, especially with the complex tours and 3D models, we have to follow certain tips. First of all, is to reduce file sizes, ensuring that large models are not there, simplifying the geometry using smaller and more efficient textures. Optimizing animations, like limit. We have to limit the animated updates to essential changes, minimizing the fly to distances for shorter movements, and controlling animations durations to avoid lags. So control visibility, simplifying tours, and regular testing are some of the other methods by which we can optimize the performance. So here is a sample tour that I have created. We can see that it would go to two different places. It would first zoom into a specific place and then would place the camera to a specific angle related to this building. Then after a certain period of time, it would transition to a different place. It would first of all zoom out, and then as we can see, it's going to a different place now. So this is our second place, and this is basically the example of the tour. So thank you so much for giving this chance to create this presentation, and thank you.